Hey guys, in this video we'll be solving the IA2 sample exam paper, which is available on the QCAA website. I've put that in the description below if you want to follow along on your own. So we'll be looking at the non-technology paper 1 today, and it covers unit 3. Alright, question 1. Solve each equation below. So for A, we know that the base is 6 for each one, so we can combine the right-hand side into one log. So we can write this as x equals, we can bring that 2 inside, so it's going to become log 6 3 squared plus log 6 4 and log 6 1, which is going to be log 6 of 9 plus log 6 4 minus log 6 1. At this point, we know that when we are adding logs, you can combine them into one bracket by multiplying them. And if you're minusing a log, it's the same as dividing by it. At this point, we know that this can be written as 6 to the power of x. So 6, the base, to the power of the answer equals what's inside the bracket, which is 36. And we know that from here, x has to equal 2. Because 6 squared is 36. Let's look at B. Alright, so they're being multiplied here. So we know that using the null factor, either EX minus 2 equals 0 or EX minus 3 equals 0. This is EX will equal 2 and here EX will equal 3. And now we can, to get rid of the E, we can do ln on both sides. So X will equal ln 2. So here, if you do ln on both sides again, x will equal ln 3. Okay, C, ln x plus ln 2 minus x equals 0. So again, we can combine this by multiplying the brackets because they're being added. And we can rewrite this as e raised to 0 equals x times 2 minus x. So we know that anything to the power of 0 is 1. Now if we expand the brackets, we're going to get 2x minus x squared equals 1. Minusing 1 on both sides, we're going to get 0 equals negative x squared plus 2x minus 1. And if I multiply by negative 1, we're going to have x squared minus 2x plus 1 equals 0. Now we can factorize this to become x minus 1 and x minus 1. So because minus 1 and minus 1 add to give us negative 2, and minus 1 times minus 1 gives us positive 1. So from here, we know that because this equals 0, we know that x minus 1 has to equal 0 by the null factor. So x equals 1. Question 2. Determine the derivative of the following functions. Let's do A. E to the x derives to just e to the x plus sine 2x. So we know that if we write this out, sine derives to cos. So we're going to have plus cos 2x. And we also have to multiply by the derivative of the bracket, which is 2. For B, let's do this. E to the sine x, we can use chain rule. In this case, we derive the power, so sine is cos x, and times the original equation, which is e to the sine x. Let's do C, cos x cubed. We can use the chain rule, so our f of x is u cubed if we let u be cos x. So the derivative is going to be this differentiated, which is 3u squared times u differentiated. So cos x differentiates to negative sine x. Just negative 3 sine x times u. And we can replace u back with what it originally was, which is cos x. So we're going to have negative 3 sine x cos x. For D, so our f of x is x plus x ln x. So we can differentiate both of them separately. So x just differentiates to 1 plus, here we have two terms being multiplied with each other, x times ln x. So we can differentiate this separately on the side here using the product rule, where y is x ln x. So our y dash is going to be, so remember product rule tells us if y is u times v, then y dash is u dash v plus u v dash. In this case, our u is x, and so our u dash will be 1, and our v is ln x. So our v dash will be 1 on x. So let's write this in. So u dash v is going to be 1 times ln x, so that's just ln x, plus uv dash, so x times 1 over x, which is just 1. And so we can write that in here, which is going to simplify to 2 plus ln x. And the last one, we've got f of x equals sine x over e to the 6x. Now we can use the quotient rule to differentiate this question. And remember, the quotient rule is if y is u over v, then y dash is going to be u dash v. So we differentiate the numerator first, minus u v dash over v squared. So in this case, our u is sine x. So our u dash is going to be, remember sine differentiates to cos x. And our v is e to the 6x, and that's going to differentiate to. So remember, it's this differentiated, which is 6, times the original function. So now let's put these values into our quotient rule formula. So y dash is going to be u dash v, which is cos x, times e to the 6x, minus uv dash. So that's sine x times 6e to the 6x, all over v squared. So that's going to be e to the 6x all squared. If we simplify this, we have e to the 6x common to everything, so it's just going to become cos x minus 6 sine x all over e to the 6x. Okay, so let's write that in. Question 3. Determine the exact value for each of the following definite integrals. Give solutions in simplest form. Alright, so for A, we want to integrate this, and we'll just be using the power rule here, so which is 4x 2 plus 1, which is 3, over 3, and we're gonna sub in 3 and 1, which is going to be 4 times 3 cubed all over 3 minus 4 times 1 cubed all over 3. That's going to be 27 times 4, which is 108 over 3, minus 4 over 3, which is 104 over 3. B, we want to integrate between 0 and 2 for 6e to the 2t plus t dt. So this will integrate to 6e to the 2t, remember, divided by the differential of the power, so that's over 2, plus this is really t to the power of 1, so that'll become t squared over 2. And we want to integrate that between 0 and 2. So 6 divided by 2 is 3, so we can just write that as 3 here. So let's do that. So subbing in 2, we're going to get 3e to the 4 plus 2 squared over 2, all minus 3e to the 0 plus 0. That's going to be 3e to the 4 plus 2 minus e to the 0 is just 1, so minus 3. Just 3e to the 4 minus 1. The last one we have is integrate between 0 and 2 for 4x over x squared plus 4 by considering the derivative of this. So let's find f dash x first. So that's going to be, so remember when it's ln of a bracket, then it differentiates to the derivative of the bracket, which is 2x, over the bracket itself. We know that this would integrate to ln x squared plus 4, but what we're integrating is 4x x squared plus 4, and we can write this as integral 2 times 2x over x squared plus 4, because the 2 times 2 will give us the 4x. This is the same as 2 times. Now this integrates to that, so it's going to be the same as 2 times ln x squared plus 4. So we can just write that here, and we want to find this between 2 and 0. So that's going to be 2 ln 4 plus 4 minus 2 ln 4. Simplify that by doing it's the same as 2 ln 8 over 4. Just 2 ln 2. So we can leave it like this, or we can also write it as ln 4 by bringing this 2 inside, and 2 to the power of 2 is 4. Question 4. The model for the average height of a eucalyptus tree is given below. Determine the height of the tree after 1 year. So for A, we want to find at t equals 1, what does h equal? So let's sub that in. So this is the same as doing 3 to the power of something equals 1, and that's always going to be 0. So log 3, 1 is 0, so it's going to be 6 plus 6 times 0, which is just 6 meters. So height of tree after 1 year is going to be 6 meters. Determine the time it takes for the tree to reach a height of 18 meters. So h equals 18, and we want to find what does t equal. So let's sub in that information. So we've got 18 equals 6 plus 6 log 3 of t. Let's minus 6 on both sides first, so that gives us 12 equals 6 log 3 t. Let's divide by 6 on both sides, so 2 equals log 3t. Now this tells us that 3 to the power of 2 equals t, so t is going to be 9. So for B, determine the time it takes for a tree to reach a height of 18 meters. So it takes 9 years for the tree to reach a height of 18 meters. Question 5. A particle moves along the x-axis with position at time t given by this equation for t between 0 and 2 pi. Calculate each time t for which the particle is at rest. So the first thing to note is the particle will be at rest when the velocity equals 0. So we know that displacement differentiates to give us the velocity, differentiates to give us the acceleration. So we are given our position function, so we can differentiate that to get the velocity function. So our velocity is going to be d on dx of et sine t. And that's going to be, so here, because it's two functions being multiplied together, we can use the product rule to find the derivative. So our u here is e to the t, and our v is sine t. and our u dash. So this differentiates and stays the original function, and this differentiates to sine differentiates to cos t. And the derivative is given by u dash v plus uv dash. When y equals uv, y dash will be given by this. So that's going to be et sine t plus u, which is et, times the derivative of v, which is cos t. And we can simplify this further by writing it like this and getting the common term, which is e to the t, outside the brackets. And each time the particle is at rest, this will equal 0. So let's sub that in. Alright, so from here we know that either e to the t equals 0 or sine t plus cos of t will equal 0. Now e to the power of nothing will equal 0, so that this is not going to give us a solution, but this will. So we can rewrite this as sine t equals negative cos t. So sine t over cos t equals negative 1, which is the same as saying tan t equals negative 1. Now, if you remember our table, so you write 0, 1, 2, 3, 4 across, and for cos theta, you write 4, 3, 2, 1, 0. You square root everything, and you divide by 2. You can also write this in pi, so this is going to be pi on 2, this is pi on 3, this is pi on 4, and this is pi on 6. So that's just 0 divided by 1, so that's going to be 0. This is going to be undefined, and this is going to be 1. So all I'm doing here is taking the numerator for the top over the numerator of the second here, because tan theta is just sine over cos, and it only equals 1 for pi over 4. So we can check on our unit circle that it's here, this is pi over 4, but we want tan theta to equal negative 1, which it will do in the second quadrant and in the fourth quadrant. That's because here we have a positive sign but a negative cos, so it divides to give us will give us positive sine and negative cos, so it will divide to give us a negative number. Here we have negative sine and positive cos, so again we'll have a negative tan value. Here it's going to be pi minus pi on 4, which is 3 pi on 4, so that's our first value, so t equals 3 pi on 4, and this is the other value that we have, which is the same as 2 pi minus pi on 4, which is going to be 3 pi on 4. And those two would be the only values that we would write, because our domain is between, t is between 0 and 2 pi. Just to answer, we can say particle is at rest at t equals 3 pi on 4 and 3 pi on 4. Okay, question 6. Determine the coordinates of the maximum point of the function f of x equals ln 2x over x for x is greater than 0. Alright, well, we know that f dash of x will equal 0 at the maximum point. So let's differentiate this function. Now, because we have a fraction with a numerator and a denominator, we can use the quotient rule. So in this case, our u is ln 2x and our v is x. So our u dash will be derivative of the bracket over the bracket itself, which simplifies to 1 over x. and v dash is going to be just 1. So let's write this in the quotient rule formula. So that's u dash times v, which is x, minus v dash, which is 1, times u, which is ln 2x, all over v squared, which is x squared. This simplifies to 1 minus ln 2x over x squared. And we know that this equals 0 when it's a stationary point. So at the maximum point. So multiplying both sides by x squared, we're going to have 0 equals 1 minus ln 2x. Taking ln 2x on the other side gives us this. We can rewrite this now as e to the 1 equals 2x. So x is going to be e divided by 2 at the maximum point. Now we want to find the coordinate. So to get the y value, we can sub in e over 2 into our original equation. So that's going to be ln 2 times e over 2 all over e over 2. That's going to be, so that's the same as ln of e over e over 2. ln of e is just 1 divided by e over 2, which is the same as 2 over e. Coordinate of the maximum point is e over 2 and 2 over e. Question 7. The spread of a flu in a certain school is modeled by the equation pt equals 100 over 1 plus e to the power of b minus t, where pt is the total number of students infected after t days. Given that the population at day 3 is 50, determine the rate the flu is spreading at this time. So we know that p3 is 50. So let's sub that into the equation. Crossing these two over, we're going to get 1 plus e to the b minus 3 equals 100 over 50. Minusing 1 on both sides gives us this. At this point, we know that e to the power of 0 equals 1. So b minus 3 equals 0. So b equals 3. So we can write our equation now as 100 over 1 plus e to the 3 minus t. And the question wants us to find the rate the flu is spreading on day 3. So we want to find dp on dt for when t equals 3. So let's find dp on dt first, and for that we need to differentiate this. So I'm going to rewrite p as 100 1 plus e to the 3 minus t all to the power of negative 1. So remember, you can bring a denominator to the numerator by making the power negative. So now we can differentiate this using the chain rule. So that's going to be negative 1 times 100 times the bracket to the power of negative 1 minus 1 all times the derivative of the bracket. So 1 derives to 0 and e to the power of 3 minus t derives to. So first we need to differentiate the power, which is going to be negative 1 times the original function. And this simplifies to, so negative 100 times negative 1 is just going to be 100. This we can write in the, bring back to the denominator now. And the negative 2 becomes a positive 2, and the rest stays the same. So that's our rate equation. And we want to find this for when t equals 3. So let's sub in t equals 3. That's 100 e to the 0 over 1 plus e to the 0 all squared. And we know that e to the 0 is just 1, so that's going to be 100 over 1 plus 1 squared, which is 2 squared, which is 4. And that's going to be 25. And we can say the flu is spreading at a rate of 25 students per day on day 3. Question 8. A particle is moving on a straight line. Velocity varies with displacement according to the rule v equals square root of 4 plus 4s, where v is velocity in meters per second and s is the displacement in meters. Calculate the displacement at t equals 2 if the initial displacement is 0. Alright, so we know that v is this, so square root is the same as having a power of half. And we want to find the displacement at t equals 2. So we know that velocity is just the rate of change of displacement, so we can write it as ds over dt is this. And because the function is in terms of s, let's integrate in terms of s, so we can take the reciprocal of this and make it dt on ds equals 1 over 4 plus 4s to the power of half. So we took the reciprocal here, so we just flipped this, and so we also had to flip this. And now I'm going to write this as dt on ds equals 4 plus 4s to the power of negative half. Multiplying both sides by ds, we're going to have dt equals 4 plus 4s to the power of negative half ds, and t will just be the integral of this. So let's integrate this. So this is going to be 4 plus 4s to the power of negative half plus 1, which is going to be half, all over half times the derivative of the bracket, which is 4, plus c. And this is going to become 4 plus 4s over 2 plus c. Now we still need to find c, but we know that the initial displacement is 0. So when t is 0, s is 0, so we can sub that in. So from here, we can write t is 4 plus 4s raised to half over 2, and plus c is really minus 1. And because we want to find the displacement at t equals 2, let's sub in 2 for t, and we want to find what s is. Adding 1 on both sides, we get 3 equals 4 plus 4s raised to half over 2, multiplying by 2, we get this. Then squaring both sides, we get 36 equals 4 plus 4s. Minusing 4 on both sides, we get 32 equals 4s. So s is going to be 32 divided by 4, which is 8. So displacement at t equals 2 is 8 meters. And that's the end of the non-technology paper.